How does a nuclear power plant generate electricity? Nuclear power plants produce about 20% of America's electricity, but most people have no idea how they actually work. It sounds complicated, and it kind of is, but the core mechanism is surprisingly simple. Let me break it down. At the heart of every nuclear plant is a reactor core. Inside that core, uranium fuel undergoes a controlled chain reaction. Here's what that means. Uranium atoms are unstable. When a neutron hits a uranium nucleus, it splits apart. That split releases energy, massive amounts of heat, plus more neutrons. Those new neutrons hit other uranium atoms, which split, releasing more heat and more neutrons. It's a chain reaction, and if you don't control it, it accelerates out of control. But nuclear plants are designed to keep it steady. So how do they control it? With control rods. These are rods made of materials that absorb neutrons, like boron or cadmium. Operators lower these rods into the reactor core. The more rods they insert, the more neutrons get absorbed, the slower the chain reaction goes. The fewer rods, the faster it goes. It's like a dimmer switch for nuclear fission. This lets operators maintain the perfect balance. Enough heat generation without runaway reactions. Now, all that heat from the chain reaction has to go somewhere. The uranium fuel gets incredibly hot. We're talking hundreds of degrees Celsius. So the reactor core sits inside a pressure vessel filled with coolant, usually water. That water absorbs the heat from the fuel and gets extremely hot itself, but it doesn't boil because it's under high pressure. This superheated water is the key to converting nuclear energy into electricity. The superheated water flows into a steam generator, a heat exchanger. Inside, the intense heat from the reactor's coolant boils a separate water supply, creating steam. That steam is under pressure, so it's forced to expand rapidly, and that's where the electricity generation actually happens. The high-pressure steam shoots into a turbine. Imagine a giant fan with multiple stages of blades. The steam pushes those blades, spinning the turbine shaft at thousands of rotations per minute. That spinning mechanical energy is then fed into a generator, basically a magnet rotating inside coils of wire. As the magnet spins, it creates a changing magnetic field, which induces electrical current in the wire coils. That's your electricity. But here's the thing. After the steam powers the turbine, it's still hot and needs to be cooled back into water so it can cycle through again. The spent steam goes into a condenser where it's cooled by water from a nearby river, lake, or ocean. That's why nuclear plants are always built near large water sources. The steam condenses back into liquid water, the pressure drops, and pumps push it back to the steam generator to be heated all over again. It's a continuous cycle. So, to sum up, uranium atoms split in a controlled chain reaction, releasing massive heat. Water absorbs that heat and becomes superheated steam under pressure. The steam expands and spins turbine blades. The spinning turbine drives a generator that produces electricity. The spent steam gets cooled back into water, and the whole process repeats. The mechanism is elegant. Nuclear plants don't burn anything like coal or natural gas plants do. There's no combustion. It's pure atomic physics converted into rotational energy, then into electrical energy. That's how a nuclear power plant generates electricity, by harnessing the incredible energy released when atoms split.